In part two of exploring absolute value, I just want to begin with this very simple absolute value graph that we introduced last time and remind you that there's this vertex where this V-shaped graph comes to a point. And we want to explore a little bit about what happens when we take this function, or this equation, I should say, for now, absolute value of x, and let's say I add 3 to it. And notice this black graph is shown right here, and that's the graph of this new equation that I just typed in. And I just want to understand a little bit about the effect of basically taking this original equation in blue and adding 3 to it. Notice that the graph shifted up by 3 units. And one way of thinking about that is every single point on this graph, including this vertex, shifted up by 3 units, translated in the vertical direction upwards by 3 units. And if you think about it, we can break this into 2 steps. Here's a number, a value of x, let's say 4. When I take its absolute value, I get 4, and that brings me to here. And then when I add 3 to that, I get 5, 6, I get all the way up here to 7. And so if I did that with every single value of x, I first took its absolute value and then I added 3 to it, then I would basically be taking every single point on this absolute value graph, the blue one, and shifting it up by 3 units. And similarly, if I instead decided I wanted to subtract 2, now you can, and maybe you've figured this out, but subtracting 2 actually causes this graph to shift down by 2 units. You take the blue graph and it shifts downward by 2 units. And again, just exploring what happens with one particular value of x. Like here, let's do a negative number. When I take the absolute value of -3, I get +3. And then when I subtract 2, I go back down 1, 2 units, and I'm here at 1. So adding or subtracting a number from the original absolute value equation causes it to shift either up or down, maybe in an intuitive way, right? If I add a value, if I add a positive number, it's going to move up, and if I subtract a positive number, it's going to move down. And in fact, what I can do is I can generalize this, and I'm just going to add a parameter, k, I'm going to call it. And this is a way to generalize this behavior. And if I follow Desmos's suggestion and add this slider, I can see if k is, the more positive k gets, the higher my graph goes. And then when k is equal to 0, I'm right on top of my original graph, y equals absolute value of x. And if k goes negative, then I'm adding a negative number, which is like subtracting a number, and the graph moves down. So that makes maybe intuitive sense, but this is a great tool for understanding how changing this formula, this equation in a certain way by adding either a positive or a negative constant will cause the graph to move up or down. And that is it for part 2 of this sequence.